Hello TaleForges! Last time we implemented a generic function and prepared collision detection. Today we'll focus on player life management and UI. Thanks to the component-based approach, we can use the player dev logic without having to implement a separate system. So let's get started. First, we need to create EnemySO, which obviously derived from scriptable object. Here we'll keep enemy type and damage. We want to select it via Unity editor menu, so let's add create asset menu attribute. As I did with the Blittable assets video, we want to transfer data directly to ECS via BlobArray. That's why we need to prepare enemy container with same fields as EnemySO. This struct will be used as data container by EnemyPool. So let's create a new struct, name it EnemyPool, and add BlobArray with enemy container. It is our enemy's data, which will be called from burstable ISystems. Last thing to do, we need to store our blob asset reference somewhere, so prepare enemy's component data, which implements the iComponent data, and create a public variable for it. Great, our data is ready to go. However, it is necessary to communicate MonoSO with ECS, because we want to use burstable ISystem, not manage system base. That's why our next struct is enemy's offering. In this MonoBehaviour class, we'll have one serialized field, list, EnemySO, and getter for baker. So let's prepare enemy's baker class, which derives from baker, enemy's offering, and implement bake method. Okay, now we can get entity with transform usage flags.none. Then prepare the create enemy's blob asset method, which returns a blob asset reference EnemyPool and takes an iRead-only list EnemySO as a parameter. It's time to create our blob builder with allocator.temp and using. It will be automatically disposed at the end of the scope. So let's construct root for our EnemyPool. This pool will be used for blob builder array. Let's allocate ref EnemyPool enemy's data with length enemy's data.count. Now we need to iterate over all enemy's data, cache necessary parameters, it as enemy, enemy type, and damage. Let's write array builder at index equals new enemy container with parameters enemy type and damage. At the end of the method, call builder.createBlobAssetReference EnemyPool with allocator.persistent. We want our data to be stored permanently. Finally, go back to bake method to call our create enemy's blob asset with EnemySO as a parameter. Then let's add blob asset ref enemy's blob asset out discard. At the end, add component enemy's component data and pass EnemyPool reference. It's time to set our data in Unity. We can prepare enemy's directory and then create two EnemySO, one for moving and one for jumping enemy. In the case of the moving enemy, I want to set damage to 1 and in the case of the jumping enemy to 2. This way, after hit 1 moving and 1 jumping enemies, we can test our lost game trigger. Player health will be equal to 3. Okay, let's go back to code. First of all, let's copy and paste getEntityCommandBuffer code from other ISystem. In the onCreate function, let's add missing RequireForUpdate for our entity command buffer. After that, let's prepare burst_compile private void execute damage logic method with parameters ref system state, native array entity damage entities, and index ref blob array enemy container enemies data and entity command buffer. First, let's cache damage entity and enemy component data via system API. Let's implement for after all enemies data. Then cache our enemy container and check if type is equal to the enemy component data type. If so, destroy damage entity via ECB and create health entity via state.entityManager.createEntity method. Let's add health component data, we'll create it in a moment, with value set to the -enemy container.damage. At the end, break to minimize number of operations. We need to prepare health component data. It is component data with value to heal or to damage, depending on the context. Now let's go back to the onUpdate method, in which we cache BlobArray enemy container in similar way that we did in the BlobAssets tutorial. Link to the video somewhere on the screen. Check it out. Don't forget to add RequireForUpdate enemies component data. And we can go through all elements in damage entities and execute damage logic. That's all in this system. Now let's create health system class. It is an system base responsible for communication between Mono and ECS. Of course, implement missing onUpdate method. Then create public event action float health updated. This will allow us to communicate with the MonoBehaviour health UI. To ensure that execution order is correct, we can add update after attribute with player damage system type. In this system, we need to add two variables: entity query, health entity query, and level system reference. Obviously, let's build health entity query with health component data. We also need to add RequireForUpdate player component data. To handle health points UI update on the level loaded, let's create onStartRunning and onStopRunning methods. In onStartRunning, we need to cache level system via entityManager.word.getExistingSystemManageLevelSystem. This way, we can subscribe to level loaded event. Similarly, in the onStopRunning, let's unsubscribe from this event. Okay, it's time to implement onLevelLoaded. As you can see, AI knows better what I want to do. Let's correct signature. Let's simply cache player component data to local variable and invoke health updated event. In this case, our AI assistants did really well. Last thing to do, we need to handle player health update and death state. So let's cache health entities and health component data array with allocator.temp. Also, player entity and player component data via system API.getSingletonEntity and getSingleton respectively. Let's iterate for every health component data, cache health entity and health component data, update player health via health component data.valueAmount, and destroy needless entity. Next, if player health is above 0, let's set isDeadState, and our lost system will automatically trigger. Then propagate changes via EntityManager.setComponentData. Don't forget to dispose native arrays. I'm really impressed by how autocomplete works in new Rider version. It's huge improvement. Great! Now let's do one micro optimization. Go to the point system and move pointsUpdated.invoke points outside of the for loop. So let's go back to Unity. Go to the system's prefab, create empty game object enemies and attach new component EnemySO. Let's add two elements to the list, moving and jumping EnemySO. Okay, it's time to implement health user interface. Let's start with code. Let's create health folder and inside it health model MonoBehaviour class. All we need to do is add a reference to TextMesh Pro. After all, we want to update the state in the user interface, right? Next, create health view MonoBehaviour class with attribute RequireComponent type of health model. Let's prepare health model variable so we can, in updateView method, set text to the current player health points. As we don't use serialize field here, don't forget to add private void awake function with getComponent health model to cache member variable. Our last script to implement is health controller, which will know about health model and health view. So, add RequireComponent attribute with both components. Then prepare member variables for model, view, and also for health system. We will communicate via it with ECS system. In the private void awake, we'll cache our variables via getComponent and health system via word.defaultGameObjectInjection word.getExistingSystemManageHealthSystem. So let's add onEnable and onDisable methods to subscribe unsubscribe from healthUpdated event. And finally, let's implement last function in this video. Private void on healthUpdated float health, inside which call healthView.updateView points. That's it. Let's go back to Unity, select game scene, and open Canvas game object. Let's duplicate points and rename it to the health. Set anchor to right corner and adjust position, width and height accordingly. Also remove point scripts and add health controller. Thanks to RequireComponent, it will automatically add health model and health view. Drag and drop reference to the health text field, then rename points text to health text and set value to health. Great! To prevent player movement jobs schedule jobs before previous one ends, let's add job handler and state.dependency. At the end, call job handler.complete. It will prevent any race conditions for entity command buffer, in the case of the player component data. Last thing to do, let's set player health to 3 points, so we can test our death trigger. During tests, I noticed I did one pretty nasty to find bug. RequireForUpdate damage entity query in the player damage system need to be called after query builder. Otherwise, it will be null reference. Then, let's go to the main scene and press play. We need to find an enemy and jump into it. Here is one. As you can see, we lost 1 health point. Now let's go to the second enemy. Yeah, we lost game. Fantastic. I would like to invite you to support us on the Patreon, where you can get the exclusive code, all models, materials or code used in this series, and access to early available content. Link in the description. Thank you for your time. I'm glad you are with us and our community is growing. See you soon in the next video.